Hi there. If you can you just announce yourself, just for the register? We're gonna make a start. I think it's almost everybody here. Let's have a look at how many people we've got. We've got 12 people now. Hi there. All right, need to. Can you just announce yourself? Okay. I'm working with two computers here, so you just heard me again talking, so you can get a rough idea of how much delay we have. Okay, we've got Hayden, Luke, Amy, Brad, Charlie, Corey as well. Okay, Georgie, hi there. Anybody else? 10 people, or 10. Hi, Callum. Ross, hello. I think it's about 10. There should be. Who's missing? A couple of people missing. I think Corey is not there, so he wouldn't show up on the list. Anybody watching together with you so that it doesn't turn up, just to get me a rough idea of where we are? I'm looking for Joe. Who else am I looking for? Sam, hi. Guten Tag, Sam. Wie geht's? Ryan is here. Great. Let's see, how many are we on the 13? That's about right. That should be the full number, full house almost. Alex, hello, Alex. Okay, Joe's there. That's great. Thanks, Georgie, for that. Okay. Right, we've got a full house. We can make a start. Okay, so this is the circuit description. I just want to go through the circuit description and then want to run you quickly through the first exercise. They're timed, the exercises, so I think the best way to get around it is I'll set the exercise like in the morning. I email the paperwork out, and then in the afternoon, or like 3 hours later, you would have to submit it on near enough 3 hours later, you would have to submit it on one file. Yeah, so that's probably the best way of doing it. Again, for these exercises, for the assignments, again, they're timed. That's the only limitation I've got. They're timed. You can use the internet, you can use your notes, you can use anything you want to provide some answers. The maximum grade you can get is just a pass. So it's not too taxing. Yeah. So as soon as you've answered the question and you've answered it correctly, then you've got the point for the question, and that will give you a pass criteria in total, and then we can finish off the unit. Also, the positive thing is with the time limit, it's not that you really, all I need is just an answer for the question. It's not that you go over the top to try and work to distinction level. I know a lot of you, for the 308 and other assignments, you've been working up to distinction level, and you've done a phenomenal amount of work. So thank you very much for that as well. It's really impressive. Just on a last note for the 308, what I've seen so far is that some of you do an awful lot of work, and unfortunately I'm not grading you on your diligence or the amount of material you produce or you write, but I'm grading you on the criteria being met. Yeah. So some of the criteria say that you have to provide extensive comments on certain things. So I'm looking for a little bit of bulk, but also make sure you prioritize your health and safety stuff. For 308, you go through sort of future proving, the handover documentation, lots of data sheets or diagrams, which support whatever you're doing. That's the kind of stuff I'm looking for distinction level. So just have a look through the criteria, through the assignment brief, which I emailed out recently, and make sure that if you want to go for the higher grades, make sure you meet all the criteria, because there's nothing more frustrating for you and for me as well if you put all the work in and you really spend a lot of work and a lot of time on the assignments, and all I can give you is a merit or even a pass because you haven't met the criteria. Yeah? So make sure I've got enough reason to give you the higher grade. And what I'm looking for is just that all the criteria are being met. So go through the list on the assignment brief before you submit it, and make sure that for every part, like for all 4 parts on 308, there's something for each point as far as possible. I think one of them is calculations have to be done correctly, and some of the assignments don't allow for calculations, some do. Yeah. A 3-phase motor, you can put some calculations in if you look on the internet, or power consumption or whatever. Same for single-phase stuff. For power consumption, you can put some math in there. For the PLC, nothing. There's no calculation. For the power supply, maybe you could just calculate the power. B times. So this is the kind of stuff I need to see as much as possible, bearing in mind that if I give you a distinction, somebody else is going to grade it as well. So we've got the internal person and the external person, and that's a problem. Yeah. So I'm accountable to somebody else as well. So if I give you a distinction, I get in trouble if I grade you too high and somebody else is going to mark it. And it's happened in the past as well that the external examiner, who has got the final word, has graded somebody down from, I'm not sure, either from distinction to merit or merit to pass. And it's always embarrassing. It's embarrassing for us, and it's embarrassing for the person as well. Yeah. So again, enough on 308. It's just a little comment which has come across. Okay, let's have a look at this this diagram here. So you've seen this diagram. So we went through this. Again, I'm quickly going to talk you through, and then I'm going to go through the questions and answers. I've got the answers on here as well. I haven't read all of them. I've read some of the answers you have sent to me, and most of them were fine, were okay. Okay, let's go through A. A is a circuit breaker. A circuit breaker could be just a manual switch. So you sometimes get these, I've seen them sort of in all companies where you've got like some sort of lever, and the lever will make contact with all 3 points at the same time. Sometimes you've got let me just scroll down and show you the circuit breaker. Circuit breakers which look like this here in A. Yeah. And they are at the same time like a fuse, if it's tripped, or if there's an overcurrent or something going through, they trip. But it's not an overload protection. I'm going to look at overload protection in a minute as such. So in this diagram, the main purpose of this thing here is to just turn the 3-phase currents on and off. Yeah, that's all it is. Okay, then we've got B. B is a contactor, and the contactor is linked with this magic box down here. Down over there you can see, I can see the mouse now. The contactor is linked with this box down here. Yeah, so we've got here the contactor, the actual contacts of the contactor, and then we've got this box here, which is wired up. Again, the contactor, we've got a start button. The start button is just push to make contact. So it's a spring loaded, so you press it down and it goes back. So you just give it one kick. So when the contactor turns on, we've got KM1, which provides a latching function. Yeah. And then we've got obviously the contactor, the contacts here with 1, 2, 3, 4, and 5, 6. So I hope you can see the mouse there. All right, okay. We've got a couple of questions as well. I'm going to go through them in a minute. What happens if any of these switches go faulty? For example, if KM1 doesn't operate, like if something is gone wrong with the contactor, and you press down the start button, what would happen is you press the start button and the motor would start spinning round, but as soon as you let your finger go, the motor would stop again because KM1 doesn't provide the latching function. Same as well, the stop button is just a sort of a spring-loaded device. So you press it down, it comes back up again. So what would happen if the spring went or you press it down and it wouldn't go back up again, and basically you could stop it, but it wouldn't start up again. So that's one scenario, which is what else have we got? We've got okay. That's so far as this contactor is concerned. So we press the start button, the contactor, we assume that switch A is turned on. We press the start button, contactor is operated. All the three switches, they flick into the closed position. This one is temporarily closed only, but whilst it is closed, it makes a contact to this one here. So that's part of the contactor, KM1. So KM1 is operated, and it provides the latch function. So it feeds power to the contactor, keeping those three contacts closed and keeping KM1 closed as well. That's a latch. And then at the same time, when KM1 is turned on, we get a green light coming on as well. So the green light is on all the time, the motor is running. Okay, all we need to do is, because that one is in the, goes back in the off position, so we either press the stop button temporarily, we break the power to the contactor opens up, those three switches go open circuit, KM1 goes open circuit, and then the whole thing is broken, and there's no more current going to the motor, and the motor will slowly stop, just spin out, and that's it. Okay, we've got the emergency stop. The emergency stop, you normally press it, so you press it in, and it sort of latches on itself, so you need a key or something to try and unlock it. So once the emergency stop is pressed, the whole line, the whole power to this whole circuit is gone, including the overload circuit and everything else, and the whole thing will just stop. So that's the emergency button. So none of the lights will light up, obviously, because there's no more power going to this section here, and that's it. One of the questions was, how many voltages have we got? We've got 415 volts and we've got 240 volts. 240 volts because the control circuit is just single phase, and we use this with respect to the neutral line here, which you can see right at the bottom here. Okay, then the last one is the C, which is the overload. Overload protection has to be special, and let's go down to the overload protector, see whether we can see it. Oh, by the way, this is a contactor, this is what you can see. So that's the block for the contactor. You've got these two switches for start and stop. Okay, here we've got the overload, and there, when you look at this unit here, there's some interesting stuff on this unit. One of the things is that little bit here, and it's a little bit of a timer. And it's very important. I'm going to talk about the timer as well. So you can tune it in, so you can turn it on to, a couple of seconds, 20 seconds, 10 seconds, 5 seconds, whatever you decide to turn it to. And this is how it works. Okay, let's go back. So when you turn on a three-phase motor, okay, hi Declan, hi Harry, just looking at the thing. Okay, when you turn on the three-phase motor, it sucks in a lot of current to start off with. And this current can go up to 7 times the quiescent current, so 7 times its normal current, or even more. So it can gobble up a huge amount of current. So the thing is, we know and we understand and we accept that it takes a lot of current, but when the motor draws in that amount of current under normal operating conditions, the overload protection really should kick in and should stop the whole thing, because something has gone dramatically wrong with the motor. So what we need to do is we need to have a system where we allow for some initial current to go through for a short period of time until the motor starts revving up, and then to for the overload to control it and make sure that there's no excessive current going into the motor to stop it from destroying itself. And so we've got this little let me see, can you see this? Yeah, just follow the mouse here. That's a little timer on here which you can tune in, and yeah, that's a little timer on there. You tune it in and you can sort of determine the time how long it would take for the motor to come up. Okay, so what's happening now is, so we turn on the motor, the overload protection notices, current is going through, the timer starts, and then for 10 seconds, for example, it allows a huge amount of current to go through without activating the overload protection circuit. And then after 10 seconds, it'll go to its normal monitoring and it'll then, let's say if the motor before was gobbling up about 7 amps, after 10 seconds the overload protection will kick in when it draws about 2 amps, whereas a normal operating current should be around about 1 ampere. Yeah. So that would be the system, roughly how it would go. And we've got the overload scenario here. I just got a message there to bring some crisps or whatever. So anyway. Where were we? I've just switched it off. I forgot to switch it off. So I'll do some shopping in a minute. So we've got the overload protection here. And we get a signal to the overload protection. This switch is activated. So it turns on, which gives us a signal to the red light. And that switch is activated here. Let me just go. So this switch is activated. So it's 97 to 98 overload. So that turns on, gives us a signal on the red light. And then the other switch, which is normally closed, is now opened. And it'll break the circuit. So it'll break the circuit to the contactor. The contactor will turn off. There's no more power going to the motor, and the motor is turned off. Yeah. So that's how the overload protection works. Now you would have to explain this when we go through the assignment. Okay. Then the next question is: once the overload has kicked in, how do we get the system back running? So we realize maybe there was an excessive load. The motor was getting really hot, and we got rid of the physical load on the conveyor belt or whatever it is, and everything should be hunky-dory now, so we could start the motor. So what do we do? So we have to press a reset button, and you can see this. So this is the overload protection. You can see this red thing here. That's a reset button. So that will jump out, and we just press it again, and it'll reset the overload protection, and then we can start again. Right, I'm just looking at your comments here. Okay, are you okay so far? Any questions before I go any further? And I have to wait for a little bit now. Let me just go back on the diagram. And it gives me a chance to have a drink of tea. Okay, I'm just waiting. Let me just type it down. Any questions before I move on? Nein, keine Fragen. Okay, that's good. Anybody else? Let me just type it down. Okay, I'm gonna move on slightly. If you've got a question, obviously there's this delay on the time, so about half a minute, round about there. I'll just stop and then refer to your questions. So I'm gonna move on a little bit. So we went through this, and this is a brief explanation. Obviously you've got this, yeah. So I just went in through there. So we've done that. Okay, let's go right down to the questions. What voltages are present in the circuit? So what I said is 415 to 40 volts. So if you come up with 400 or 380 and 230, that's fine as well. So they're just the European levels. The next question is, Let me just highlight this. Why is it necessary to have a circuit breaker and A on the diagram in addition to the contactor? In addition to the contactor. So that's a question. And the answer, the circuit breaker will isolate all of the circuit, including the control circuit. So the contactor, obviously you need the control circuit, but with the circuit breaker, you can isolate everything. So even the stuff that is hooked up to light through. Let's go back quickly to show you. So we've got the circuit breaker here. So just follow the mouse, that's the circuit breaker. And then we've got, after the circuit breaker, one line for the control circuit. So obviously when we turn the whole thing off, we want this line to be dead as well, just in case there's a problem with the control circuit and we need to work on it. And obviously we can't have the control circuit after the circuit breaker because otherwise it would never be able to switch itself on. So we need to have this before. Hence the circuit breaker or the switch has to be before the contactor. Okay. Right, let's move on. The next question number 3, I'm on now. What type of switch is the emergency stop? And actually push to brake is not really the full answer. It's not just push to brake, but it locks in as well. So once you press the emergency stop and you brake, it stays in the it stays latched into the brake position, so into the open position. So the switch, once it's open, it stays open until you manually reset it. And very often, I mean, some emergency stop systems, they've got keys or something like that. Have I got a picture of an emergency stop button here? I don't think I have. Okay, so that's the answer for that one. Number 4. In this circuit, is it possible for the red and the green light to be turned on at the same time? And the answer is no, it's not possible. When the overload is activated, the switch OL9596 will break the circuit, causing the contactor to be turned off and the latch to be broken. So in this circuit, is it possible for the red and green light? Okay, right, let's have a look at this one. So is it possible for the red and green light to be on at the same time? And the answer is no. So when this light is turned on, and that switch, let me just put this on. So this light is turned on, and that switch OL 9798 is put into closed circuit. So current is going to go through this light. Red light turns on, and then the other switch, the other overload switch, is going to be put into the off position. So it's going to be an open circuit. And so there's no more power going through any of this part of the circuit here, which means the contactors will disengage, and the green light will also not be on. So it's impossible for the red light and the green light to be on at the same time. You can press the start button as much as you want, because there's no more power going to it. The green light is not going to come on. Right, let's go down. Question number 5, I think it is. Okay, what is the purpose of switch KM1? So I'm on this question here now. And the answer is, once activated, it'll keep current going to the contactor control circuit to keep it latched on. So it's just like a latch-on switch. It's part of the contactor, but it's used for the control circuit, and this is just to keep the contactor in its activated position, so to keep the contactor, keep it latched on. Again, I'm going to go back to the diagram. So you've got KM1. So once KM1 is activated, which will be as soon as the contactor gets some power, so it'll feed power to the contactor, and the contactor in turn will keep the switch turned on. Let me just use the mouse here. So this will keep feeding power to the contactor, and in turn the contactor will keep the switch in the on position, so it's making contact and keeps the contactor fired up, regardless of what's happening with the start button. Okay, next one. So it's question number 6. Question number 6. So this is a question now we are looking at. What has an overload protection circuit got to deal with when it is used for a three-phase motor? What are the main issues with the current inrush on a three-phase motor? So that's what we said earlier. When a three-phase motor turns, it will have a current flow up to 7 times higher during the starting phase. So the overload protection should not activate during this phase. Once the motor is running, a current 7 times its normal operating current would indicate that fault conditions, and the overload should turn off the circuit. So we've got this high current and normal operating current. High current when it turns on, and then once the motor is running, we've got the operating current. But if you get the starting current during its operating time, we know something is drastically wrong. The motor is going to heat up beyond its design capability, and the overload really should kick in to isolate the motor. So that's the whole thing. And again, I'm just going to go back to the unit here, and that's the reason why I've got this little timer thing here. And this timer function allows the motor to turns on, then the timer kicks in, and the motor can start up, and the overload protection is not going to kick in until the motor is running. You might have a separate circuit. You might have like circuit breakers which have got like a fuse setting which kicks in at 20-30 ampere, just in case there's something dramatically wrong. But again, for the overload protection, we don't need to let it kick in at 20 amps, but if the operating current is 1 ampere and it continuously runs at maybe 3 or 4 ampere or 2 ampere, then that thing should kick in and take the motor out of action, because the motor is going to destroy itself and something is wrong. Okay, let's have a look at the next question. So we've got question number 7. We've got the overload protection is activated due to an excessive load on the conveyor belt. Motor is driving. The motor stops and you've removed the excessive load. What steps would you have to take to get the motor back working? And it's just reset the overload protector, start the motor. Again, when you look at the unit here, you've got the little red button here, and that's a reset button. So if that thing is activated, then all I need to do is, obviously after the motor is okay and the reason why it kicked off has been removed, is press a reset button and reset the overload protection. And then everything will be fine. We'll be living in a happy world. And then obviously the other thing is, okay, when I go to this one here, so we've got the reset button somewhere here. You can't see it in the diagram. It's not there in the diagram. But then again, might be this bit here. Let me just point out on this. That thing here which indicates that this is a reset button. So we reset the circuit, and then obviously we need to press the start button for the motor to get back into motion. Right, next question. Question number gets easier now. Okay, we've got some problems here. And again, some of them you need to think your way around. So if you didn't get this, it's okay, don't worry too much about it, but I just wanted to stretch you a little bit and try and get you to think about how this circuit works. We've got a start button. The start button is faulty, so that when it is pressed to make contact, it stays in the closed position, i.e. it's permanently activated. How would the fault show up? So the start button is permanently activated all the time now. So the motor would start and run as normal, but when the stop button is pressed, the motor would only stop whilst the button is pressed down. Let me just remove the mouse. As soon as the stop button is released, the motor would speed back up again. In this scenario, the only way to stop the motor is either through the emergency stop or the circuit breaker A. So if your start button, was not like the spring in the start button would have gone, you press it down and the contacts just stay on. That's what would happen. So the motor would run, but you could turn it off with the stop button, but only momentarily. And then as soon as you let your finger go from the stop button, the motor would come back on again. And then the only way to really take it off permanently is using the emergency stop or the circuit breaker. Again, it's just sort of to make you think about it. So when you service these systems, and I bet when you go to Hovis or to Coca-Cola, you probably have got hundreds, if not thousands, of little motors. and they pretty much all have got the same system. It's a similar system to that one. Yeah. So if you get your head around this and you get like a weird fault cropping up, you might remember this lesson and then aha, it's just like that bit is wrong or that bit, or I need a new contactor, I need a new control unit, or there's something wrong with the overload, and so on. So it just helps you to narrow down where the problem is. Okay, let's have a look at the next one. We've got question number 9, we've got switch KM1. Switch KM1 is an issue so that it doesn't make contact. How would the system behave? The motor would start, so that's the answer. The motor would start whilst the start button is depressed, but would stop as soon as it is let go. Again, if you look on the diagram, we've got the we've got a KM1, which is here, so that's connected with this box here, the little contactor box. So if that one doesn't work for whatever reason, like it's broken or whatever the reason may be, or the contacts are carbonated or something, so all you would have to do is you would have to press your start button, the motor would kick in, would turn around, and as soon as you let the start button go, it would just turn off again. And that's the problem with the switch KM1 being broken. So you can't, and I mean the whole thing, I mean these are just an integrated unit, this and that and this switch here. So you'd have to probably change the whole contactor unit. That would be the easiest way to do. It's not the start button that's faulty, when you get this fault, but it's KM1. Right, next one. Where are we? Question number 10. What would happen if the 240 volt line would connect to LO1 or instead of LO2? Yeah. So 240 volt line connects to L1 instead of L2, and then the answer is nothing. Everything would just work as before. So it doesn't really matter. So if again I go back, so let's have a look. So we are talking about this line here. That's a 240 volt line. And what would be the difference if I just connected it to L1 instead of L2, or maybe even L3? And the answer is no difference whatsoever. It would just work fine. Everything would work fine just as before. So it doesn't matter which line you connect it to. Okay, let's move on. Next one. Question 11. The light has gone faulty. The green light has gone faulty and doesn't light up anymore. Would the motor still run? And the answer is yes. Yeah. So it wouldn't affect anything. Again, let me go up. So the green light doesn't control anything. It's just powered up by the general circuit. So if this light goes faulty, the motor would still run, but you just wouldn't have any indication that it is running on the control board. So everything will work fine other than the light doesn't light up. And if you imagine, I mean, this setup could be somewhere in a control room, could be quite some distance away from the motor. So you wouldn't have a clue of whether it's turned on or off. So the motor would run as normal, but the green light wouldn't indicate. What they normally use is LEDs, or they use bulbs which are working on 240 volts. And they tend to last very long, so they don't use like normal tungsten bulbs which burn out after 10,000 hours or something. Like a couple of years you used to have to change tungsten bulbs, but they tend to last a long time, so they use slightly different technology. And in theory, I mean, it doesn't always work, but in theory they should pretty much last the lifespan of the control unit. But you never know, it might be just bad manufacturing defect, and they die before their time. Okay, next one. We've got question 11. Question 12 now. Okay, the winding in the motor, which is connected to L2, has burned out and is shorted out halfway through through causing the motor about 3 times the current to be pulled in. What do you think would happen? So again, just didn't write this right, did I? The winding in the motor which is connected to L2 has burned out and is shorted out halfway through. Okay, so that's it. Causing, I should put a comma there, causing about 3 times the current to be pulled in. So it causes about 3 times the current to be pulled in. What do you think would happen? And again, it depends how the overload is set up, and the overload would monitor each phase for that same reason, because it might just be a problem with the phase. It might not be all three phases together that get too much current or demand too much current. And it says here, most likely the overload would kick in and the motor would stop with the red light being turned on. Yeah. So that's basically what would happen. So if you get about 3 times current, depending how the overload is set up, it should really kick in and stop the whole thing. And again, the way to find out what's going on with the motor, you would do an insulation test. So if it's burnout, there's a good chance that there's some leakage to earth. Or you test the resistance. If some coils have burned out and some of the windings touch one another, cutting out about half the coil, you will notice that the resistance has gone down as well, depending how it is and what's happened inside the motor. But some of the readings will be off. So you do a resistance measurement, so it's low resistance like 0.2 ohms or maybe 3-4 ohms, something really, really low. And then you do an insulation test, and the insulation test should be in excess of 2-3 mega ohms, and if it goes right down, there's a problem somewhere. Okay, number 13, the stop switch has gone faulty, so that when it is pressed it doesn't reset or go back. How would the fault show up on the system? And this is sort of the answer. The system would stop, but afterwards it could not be turned on again until the stop switch is replaced. So again, when we look at the stop switch, where's the stop switch? Here we go. Stop. That's the stop switch here. So it's normally in a closed position. So if I open this temporarily and the spring doesn't push the contact back, it'll stay in the open contact position or open circuit position, and the motor is going to stop, but it's never going to turn on again, because that thing would just stay in open circuit position. So all you can do is at that point is just replace the stop switch. Okay. Go back. Feel free to stop me if anything is not clear. I'm sort of just rattling through the questions. But again, this is the whole purpose, with the chat room. If you've got a question, feel free to just fire them at me. Okay. What have we got? We've got green with the motor still on. Where were we? Stop switch. Okay, 14. Almost done here. Would the overload protection still work if the red bulb is faulty? The answer is yes. Okay. Again, let's go back to the diagram. So we've got the diagram here. So if this light doesn't light up because the filament is burned out or something, everything would just work as normal. The overload protection here, 95 and 96, that would still work, and that's the main thing. That would knock off the whole circuit, and the motor wouldn't run. The only problem is you wouldn't have a clue, why it stopped. Is there a fault with the stop switch or with KM1 or the motor itself, the circuit breaker? But you wouldn't necessarily know that it was an overload issue. So that's a problem if the red light doesn't come on. But otherwise, everything would just function as normal, as it's been designed to function. And we've got the last question. And what would happen to the circuit if the 240 volt line connected to L2 disconnects? The motor would stop running. So let me just highlight this. The motor would stop running, the control lights are dead, and it is not possible to turn on the motor. So again, let me just go through the diagram. This is the line here, so that's the manual switch line. So if that one disconnects, then this whole circuit, obviously, the overload protection, the contactors and everything would not be powered up. And because they aren't powered up, nothing would happen. Everything would just stay off. So again, if you've got a fault on this line, then the whole motor just wouldn't work. You could do what you wanted. And it's something to test out. So once you've got a good understanding of this diagram, it's a couple of things you can do for fault finding. and then maybe it might just be, that the terminal has gotten loose inside inside one of the control boxes, or something like that, and it might just be a 5-minute fix to try and get it back on. My experience in industry has always been, if it doesn't work at all, these faults are pretty easily fixed. You do a couple of tests and you get them. The worst faults you're dealing with are intermittent faults, where something is not running right or not quite running right, or it stops and then it works again, it stops, it works again. They're the worst faults to track down, and it takes you ages to try and find what's gone wrong, because by the time you are back on the equipment, the fault condition has disappeared, and it's hard to look for something that isn't there, for the moment in time. And so it's just a nightmare. So my experience was, if some item is completely dead, nothing works, they're the simplest faults to deal with. I don't know what it's like for you, where you work. I know you're working on equipment as well, so you might have your own experience by now. Right, I'm done. What's the time? It's 45 minutes, so that was about the plan. I thought it was between half an hour, 45 minutes to go through this. You will need this information. I'm going to upload an awful lot of stuff. I still have to figure out how to do it. So my plan was so far that I use a web address. I've done a lot of or a bit of web design for companies and stuff like that. I use one of those domains I've got control of, put a subdomain in, and I'll send you a link. And when you go to this link, you will get a listing of all the documents which are available, and you should be able to download them. Yeah, that's the plan for now. And I have to do it tomorrow morning or something. Okay. So I'm going to give you... No, I'm going to do it tomorrow morning. Yeah. So the way we're going to do it is tomorrow morning I'll have a session. And I'm going to talk you through the first paper. Then you get a 3-hour window to do this in. And I may do it over lunch, so you have your lunchtime, and you can use your lunchtime for the assignment or for lunch, depends what you want to do. And then there's going to be a time where I need you to upload it to OneFile. And I'm going to go on OneFile, I'm going to look for the documents to turn up, either on OneFile or email them to me. And then that bit is done. And then what have we got? Tomorrow we've got Thursday. I'm not sure on Friday. We might be able to do one on Friday as well, and then maybe one on Monday, or maybe 2 tomorrow, depending on the timing. Yeah. The time to meet tomorrow is somewhere between 10 and 10:30. I'm not sure how much time I need to set it all up. I make all the documents available to you, possibly tonight, if I get it all done. I'll email the link out. Then, again, once you get the questions, you've got 3 hours to look for the information from wherever you want to. You can use the internet, you can use the notes, you can use the presentations I've given you. And that's it. The next question is, have you all got access to PowerPoints, or do you need them in a different format, like in PDF or something? That's the next question, and I'm not sure whether I can do this with the software I've got available here at home. Okay, I'm just going to wait for the answer, and then can you deal with PowerPoint PPTX presentation? So that's the latest version of Word. You should be able to when you use Office 365, which I think you've got access to. But if you can't, let me know. Now's the time. So I have to do some magic to try and make them available in a different format. Okay, let me just type it out. Okay, getting answers coming through. More importantly, if you can't, let me know, because then I have to sort of... I'm not sure whether I can do this here. I have to convert them into PDF or make them available in PDF. All of Office 365. Okay, you should be able to do it through Office 365. Can you all access it? I assume so. Anyway, now's the time. If anybody has got problems, please shout out, let me know. I don't want you to be disadvantaged. Okay. No more responses? Or okay, I think I've got most of you. Right, okay. So tomorrow, 10-ish, 10:30-ish, I'm going to send an email out shortly before. I'll let you know, probably with the email which I sent out. I might send one out tonight. I will send one out tomorrow for sure, where you can find the presentations. Then we will have this time limit. Yeah. So also, if you can't do it, let me know. Then you will get a different paper. If for whatever reason you can't use this time limit, or if you have to shift the time slightly. So my thinking is maybe from 11 o'clock to 4 o'clock with your lunchtime. That should give you about 3 hours. And then in the evening I will look at... okay, Sam, okay, great. I will look at that everything is there. If it is there, then everything is okay. I'll try and grade it the same day. And as I say, it's only pass or fail. So you either answer all the questions, you answer them correctly, you get your pass. If you answer any of the questions not correctly, incorrectly, it's going to be a fail. Yeah. Okay, I'll just leave it at that. I'm gonna... tomorrow the session is going to be very, very short. It's just going to be... I'll talk you through the assignment, and then I'll email it out to you. I'll email it out to you at the beginning of the session, so you've got it available if you want to, and you can look at it whilst I'm talking to you. I'm quickly going to talk you through. Then I'm going to set the start time, and then you'll do the assignment. Yeah. So about 11 o'clock, I think that's the starting time, and then for the assignment to be done by 4-ish. Yeah. And I'll be checking it around about 5-ish. Okay, that's all. Any questions, anybody? Okay, I'm going to wait for a bit before I end the stream. Let's have a look. Everything seems to be okay with the stream so far. 25 dropped frames. Yeah, everything should be okay. Okay, I'll end the stream at this note. I wish you a good afternoon. Enjoy the sunshine. Here it's pretty nippy outside. I don't know what it's like where you are. It's like fake sun. You go outside and you think it should be really, really warm, but it's actually quite cool. Even the cat doesn't like it outside at the moment, so she prefers to be inside. She goes out for a bit and then she comes in very quickly. So, can we upload the questions to one file? Yes, you can. Yeah. Ideally, everything on one file. Yeah. Predominantly on one file. Again, as I mentioned before, I think one file is getting checked by some of the assessors. And I think Gary checks it, and he needs to see activity on one file. And I think senior management as well. They want to, find out whether there's any teaching going on or not. And that's one way for them to test it, that there's some activity on one file. So whatever you do, if you email it to me, please also upload it to one file. I may not comment on the answers for those questions. But by the way, this what we've done today with the answers, I'm going to email it to you as well, so you've got the answers. But the answers you've written yourself, even if they're not spot on or 100%, don't worry, just upload them. You're not going to be getting graded down or anything if you get a wrong answer to any of those questions. It's just to see that you are working and that you are engaging in some activity. That's what it's all about with one file. The assignment brief at the end, not the assignment which you'll be doing tomorrow, that should be on one file as well, predominantly. Also email it to me, just in case something is going wrong. Sure. Right, good question. What if you don't know how to upload to one file? Because I don't know how to upload notes. I'm not very good on one file myself. I'm not struggling. I'm just sort of working my way through. I don't think it's very intuitive software. Can you ask some of your colleagues who have done it, on site to show you? It's hard to show you, obviously to talk you through without sitting in front of one file. But again, Hayden, if you email stuff to me, I can upload onto your account as well. So, but please don't all email the stuff to me. If you know how to upload it to one file, please do it on there. Yeah. Right. Otherwise, I'll see what I can do. I'm not sure what I see on one file is the same, as in assessor/lecturer. It's the same as what you see on one file. So it's going to be hard for me to. I don't have the student perspective to talk you through that unless I was sitting next to you and just looking on the system. Okay, Hayden. For now, just email stuff to me and I'll upload it for you. Okay. Right. That's a note. That's a thing. I think we've talked about everything. I'll see you tomorrow, about 10ish, 10:30ish, and then I'll send out the assignments. Feel free to not feel free. You have to do them, tomorrow during the day, and then on Friday you'll do the next assignment, and then the last one should be on Monday sometime. Okay. Right, on this point, what's the time? We are close to 1 hour. I'm gonna end the stream, and I'll see you guys tomorrow. Okay, have a good afternoon and enjoy the rest of the day. Okay, bye bye.